Good morning, everyone. Welcome to the presentation of our project Phase 2, which focuses on the development of an allergen detection bench. Through innovative technology and rigorous research, we aim to provide a comprehensive solution to enhance allergen awareness and safety. Let's dive into the key aspects of our project and explore how our allergen detection band makes a meaningful impact. Our project guide is Professor Nita M. Pichu, Department of Electronics and Communication Engineering, and the group members are Anu Tisato, Krishnapriya R, Maria Joy, and Nobin Thomas Mecho. These are the contents included in our presentation: the introduction, objectives, target users, need metrics, target requirement, block diagram, design specification, circuit diagram, use case diagram and sequence diagram, component specification, bill of materials, work plan, software requirements, result and discussion, achievements, conclusion, and reference. Introduction. Over the past 2 decades, the deaths caused by pollution have increased by 66%, and it is estimated that the pollution causes more than 9 million deaths globally, in which over 6.5 million deaths are caused due to air pollution, and this number is increasing. Pollution includes the contamination of air by particulate matter, the PM2.5 and PM10, ozone, oxides of nitrogen and sulfur, and other modes of population pollution. And according to the World Health Organization, the common air pollutants include ozone, nitrogen dioxide, sulfur dioxide, carbon monoxide, and particulate matter. These pollutants can have adverse effects on living bodies, and thus it is essential to ensure clean air for maintaining good health. The environmental factors such as dust and pollutants trigger allergies that affect millions of people, leading to discomfort, health complications, and reduced quality of life. In light of these challenges, we present the proposed system Allergen Detection Band, which is a wearable device that can alert individuals or allergic sufferers to high content of allergens in their surroundings or homes. These are the objectives. Our objective is to create a wearable device to monitor the environment and analyze the allergy causing substance and air pollutants such as dust, humidity, temperature, and toxic gases with the help of MEMS sensors, the microelectromechanical system, and artificial intelligence. And the sub objectives include real time notifications will be sent to individuals when they enter an environment with elevated levels of allergens. Collaboration with healthcare professionals can be done to improve allergen management and treatment. Personalized recommendations will be provided based on the individual's allergy triggers and specific health conditions. These are the activities completed so far: survey and target identification, block diagram design, components identification and integration, basic circuit testing, output visualization on Blink and Firebase, circuit design, PCB layout and soldering, and casing. Target users. The first two represent the primary target users of our project, and the other two represent the secondary target users. The primary target users are individuals with allergies. All individuals, such as children and adults who suffer from allergies, can use the system to monitor allergen levels in their homes and take appropriate measures to reduce exposure. Asthma patients are often sensitive to allergens, and an allergen detection system can help them identify and eliminate allergens from their living spaces to manage the condition better. And the secondary target users, such as medical shop owners, can earn a profit by selling of the allergen detection band, and the allergen researchers can use the system to collect data on allergen levels in various environments, aiding in the research and understanding of allergies. This is our need matrix, which shows a direct relation between our needs and the matrices. The primary needs of our project are: the band should be lightweight, affordable, the band should have a good battery life, it should be easy to use, a- good accuracy, the band should be wearable, and it should send an alert. Target requirements. Accurate allergen detection. The system must accurately detect allergens including dust, humidity, and toxic gases. Real-time alerts. The system should provide real-time alert to users when an allergen levels exceed safe threshold, ensuring immediate action can be taken. IoT connectivity. The band must be IoT enabled for data analysis and user notification. MEMS sensor integration. The device should integrate MEMS sensors for allergen detection due to their high sensitivity, rapid response, and compact size. Customization. Users should be able to customize allergen alert settings to suit their individual needs and preferences. Comfort. Users need an ergonomic and comfortable wearable for extended design sessions. User friendly interface. The smartphone app should provide a user friendly interface. These were the target requirements of a project. This is the target specification.
This is a block diagram of our project. The core component is the microcontroller unit, functioning as the central processing unit for data management and control. It processes data from multiple sensors. The gas sensor, responsible for detecting toxic gases such as carbon monoxide, NO2, and the temperature and humidity sensor, providing vital information on environmental comfort. The dust PM2.5 sensor, which monitors air quality and potential allergens, and the atmospheric pressure sensor, an indicator of atmospheric changes. So, these sensors collectively gather essential data that the microcontroller analyzes and communicates through the Wi Fi module. The Wi Fi module enables wireless connectivity, connecting the system to a user friendly mobile application on the user's smartphone. The mobile application serves as the primary interface for real time data access, user customization, and educational resources. The power supply ensures the system's energy requirements, and rechargeable battery stores energy from various sources to maintain an interrupted operation. This is the use case diagram of our project. A use case diagram is a graphical representation of interactions between users and a system, depicting the functional requirements of a system. This is the explanation of our use case diagram. We have actors. Mainly, actors are entities outside the system that interact with the system. They could be users, external systems, or even hardware devices. We have user, doctor, server, serviceman, and environment as the actors. And we have the use cases. Use cases mainly describe the interactions between actors and the system to achieve specific goals. The relationships are different types of relationships between actors, and they are represented as the lines. So user has access to the power on button, LED button, the charging module. The doctor also has access to the power on LED button and charging module. The serviceman will have access to the control unit as well as the service option on the application. The environment mainly has the connection to the sensor on the allergen detection band. Next, we are going to discuss about the sequence diagram of our project. Our sequence diagram has the following objects: user environment, sensor, control unit, Wi Fi module, cloud server, application, and the user. The sensor will get allergen data from the environment, and the control unit checks for data from the sensor, represented by check availability, and gives return status to the control unit along with the sensor data. The control unit will send a connect request to the Wi Fi module, and a return acknowledgement will be sent by the Wi Fi module, and then the output data will be transferred to the Wi Fi module. Wi Fi module sends a connect request to the cloud server, and the cloud server will send back a return acknowledgement, and then data will be uploaded into the cloud server. And the cloud server will send back a return acknowledgement, and the data will be uploaded into the cloud server. The cloud server will send a connect request to the application, and it will send a return acknowledgement. Then the data will be transferred and can be visualized through the application. Application send alert to the user. User can also set user data to the application to receive alert about threshold level of allergen.
This is the circuit diagram of our project. Our project focuses on the idea of creating a wearable band that detects air pollutants such as carbon monoxide and nitrogen dioxide based on the AQI parameters, air quality index, temperature and humidity, the presence of dust particles PM2.5 and PM10, and the air pressure. The Atmega 328P serves as a main controller in the circuit schematic. It is connected to the temperature and humidity sensor, the DST11, BMP 180 for atmospheric pressure, MICS 5524 for detecting carbon monoxide, dust sensor, the GP2Y, and the NO2 sensor. Pin 7 Pin 7 and 20 of the Atmega 328P is connected to a 5-volt power source, and the 8 and 22 pins are grounded. A 16 MHz crystal oscillator is connected to the crystal pins 9 and 10, and each leg of the crystal oscillator is linked to a 22 picofarad external capacitors, with the other end of each capacitor connected to the ground. The oscillator's performance is stabilized by the capacitors. The sensor PMB180 uses the I2C communication interface. The STA and SCL pins of the sensor is thus attached to the pins 27 and 28, STA and SCL respectively on the microcontroller. The BMB180 and DST11 requires a 3.3 volt supply, but the MICS 5524, GP2Y dust sensor, and the MEMS NO2 sensor require a 5 volt supply. A 3.3 volt supply is also required for the Wi-Fi module. The 3.3 volt voltage regulator in the power supply circuit ensures this, and another voltage regulator with a 5 volt output exists to ensure a 5 volt stable supply to the microcontroller and the other sensors. The Atmega's 328 the Atmega's TXT pin is linked to the RXT pin of ESP8266 and vice versa. The output pin of the 3.3 voltage regulator is linked to the VCC pin, and the enable pin is kept at logic 1. The positive is connected to the V-in pins of the two voltage regulator, and the output gives 3.3 volt and 5 volt respectively, which is connected to the main circuit as per requirements. These are the component specification. The main component of the project is the microcontroller, the Admega 328P, the ESP8266 ESP01, which is the Wi-Fi module used in the project, the DST11 sensor for detecting temperature and humidity, PMB180 sensor for detecting the atmospheric pressure,
MICS 5524 is a gas sensor which detects carbon monoxide. SEN 0574 is also a gas sensor which detects nitrogen dioxide. GP2Y1010AU0F is a PM2.5 optical dust sensor. This is the bill of materials. This was our work plan based on which we completed our project. These are the software requirements. Arduino IDE. Arduino IDE is a software platform designed for programming, compiling, and uploading code to Arduino board, facilitating the creation of electronic projects. EasyEDA is a free and easy to use online tool for PCB design, circuit simulation, and schematic capture. Blink. Blink is a versatile and user-friendly IoT platform that enables developers to create and control IoT projects through the mobile apps. Result and discussions. This is the PCB layout of the circuit. This is the PCB layout of power supply circuit. This is the breadboard level implementation and PCB. This is the code running in Arduino IDE and sensor output on Arduino IDE. This is the output obtained and the reading displayed on the blink arc. These are the achievements. Smart Indian Hackathon 2023. As a part of finding solutions to certain problems, we submitted our idea, allergen detection band, and actively participated in the Smart Indian Hackathon 2023. Submitted our conference paper titled Air Guard Wearable IoT Enabled Allergen Detection Band for AQI Tracing and Allergen Triggers with AI Interface to IEEE AMED 2024. Submitted our conference paper titled Air Guard Wearable IoT Enabled Allergen Detection Band for AQI Tracing with Allergen Trigger with AI Interface to IEEE ICECCT 2024 and IEEE AMED 2024. And also we submitted our conference paper to IEEE ICST CE 2024 and IEEE SPICES 2024. Now let's move on to the conclusion. The allergen detection band provides real-time monitoring, immediate alerts, and data collection capabilities, empowering users to make informed decisions and manage their allergies effectively. This innovation solution extended its impact to workplaces, creating safer environment and promote healthier living by enhancing indoor air quality. Integration with smart home systems to automatically control ventilations and air purification systems. These are the references. Thank you.